think growing up, I thought of architecture as being extremely static. Buildings did not conform to the human body nor to human nature. So my question when I finally got to architecture school and out to this very day is, why can't architecture accommodate the human? Maybe it's a lot better if we make it respond, so that looking at a building and considering it more like a skin. Over time, I've moved more and more towards the technology side of architecture and realized that I had to compete in the world of building technology. I researched and designed and tried to use thermal bimetals in architecture. Basically what it is a lamination of two different metals together. Metals expand when heated, and so when these two different alloys are heated at the same time, one will expand more than the other. And as a result, the metal curls. I first found the metal on a lamp. As the bulb turned on, that gave off enough heat so that the hood of the lamp would open up. And I thought, why can't we use this as a surface material to architecture, as a way to control the amount of air passing through for ventilation or potentially for shading purposes, so it's automatic. You can see here, this is cold, everything's flat. And when you start to heat it up with our heat gun, all the pieces start curling. The material starts to pivot at about 70 degrees, and it'll continue curling until something more like 400 degrees. The intention of Bloom was trying to make a project that would actually be outside and react to the sun. The shape, for example, the aesthetics came out of it being virtually a big sundial, and that it has this very circular or radial type of shape that would be facing the sun at different times of day and therefore can react. And because of the different times of day and the different shading requirements and potential ventilation, the surface was differentiated at all locations to react in different ways. We were really dedicated to trying to use Grasshopper from beginning to end in this project. So not only was it useful in making the form, but it was very useful all the way down to determining the files and the fabrication files of the tiles. There's about 9,000 tiles of bimetal on there, and every single one is different. There's another 3,000 frame pieces, and no two are shaped alike. But we were able to fabricate them in a way that we did not have to design and build every single one by hand from scratch. The pattern making and the variation in all the pieces was built into the software. You can see in this model right now, it's connected with other solar analysis tool files and overlaid together. And you can see the red areas on the surface are the parts that have the most exposure to the sun. If we did not have these software tools, there is no way we could have produced something like Bloom. One of the areas that we're working is trying to produce some window systems. So if you can imagine on a south-facing or a west-facing glass wall system, these bimetal walls can be either inserted within the glass system, within what we call a double skin facade, or even on the outside as a brise-soleil. They can start to shade automatically and with zero energy the sun and the sun penetration to the building, which is a big deal because we have a lot of heat gain, especially in Los Angeles where I am, to the sun from the outside, and it would lower costs for air conditioning and in effect and indirectly also reduce the amount of heat island effect. There's a project that we call Tracheolus that was completed less than a year ago, and it's a concrete block system where it's an idea about having the heating and cooling system within the walls of the building, and so they would radiate the temperature as opposed to being forced by a forced air system. So what you can see here is the infrared heater just turned on as the red light, and as it's coming up through the valve system here. You see this starting to operate here. As the air is heating up in this chamber, will then open the alternating pieces as you go up. There's definitely a message that I'm trying to say, and it goes back to that idea of how architecture can be responsive. You do want to look at architecture as something very stable. You don't want the ground to move, and you don't want, you know what I mean, the walls to move in and out, but maybe our fundamental understanding could be wrong, right? Maybe we need to be thinking about how everything should be changing and moving, and that the aesthetics of it cannot be determined by what we think something should look like. So a house, because it looks like a Monopoly game piece shape, is maybe not the best shape or house or material to be built out of. We need to think of new ways.